Greetings, folks. Joseph Kursky here with you to investigate hydrology using spatial technology with you all. Now, we as geographers love looking at the world through wetlands, ocean currents, river systems, watersheds, etc. And you can do that with the data and tools at your fingertips with spatial technology. Let's get started. In the upper right of any map that you might have open in ArcGIS Online right now, maybe it's the landforms map or just a new blank map, but go ahead and modify map. Use modify map, then add, search for layers, and search for World Hydro. World Hydro. Select the ESRI Hydro Reference Overlay, one of my all-time favorite data layers. I mean, what's not to love? You'll see why, hopefully in a bit. Go ahead and add it to the map. It's the ESRI Hydro Reference Overlay. Go back to your contents once you've added it for your map and note that you now have a hydro layer showing rivers and tributaries. Turn off all your landforms layers or whatever else you've got in a particular map right now. Go ahead and change the base map to terrain with labels. And right here, this could be the end of the investigation, right? If you had your students looking at the relationship between terrain and where rivers flow, that in itself could be a lesson right there. But if you want to dig deeper, let's keep moving on. For example, if you just wanted a map of rivers of Australia, now you've got one. So this is good for content as well as tools and investigation. If it helps visualize the political boundaries, feel free to change the base map to National Geographic or another base map. Which direction do most of the rivers flow in Victoria? Why? What is the nearest river to your school? How far away is it? Those are the kinds of questions you can ask and have your students investigate right here. And again, that could be the whole lesson right there. But if you want to keep digging deeper, let's keep going. You've done a lot of good work already in this map. You've panned and zoomed and you've changed the base map. So it's a good idea to save it so you can do some analysis on it later. And also so that you can return to the map as you left it right here. So for example, zoomed into Victoria. That would be how the map would open once you saved it and came back to it later on. If you do save and share it, give it a suitable title, tags, and a summary. Now, let's tap into the power of GIS. Now that you're logged in or signed into ArcGIS Online, you have analysis tools at your fingertips. And we're only going to dig into one analysis tool here, but realize there are a good set of analysis tools at your fingertips. The tool that we're going to use is something called Trace Downstream. Now, if you're signed in and the analysis tools do not appear, then you need to contact your administrator for your ArcGIS Online account and make sure that you're granted publisher permission. You need to be a publisher to have those analysis tools appear. And the reason why is because when you run the analysis tools, you actually publish data into ArcGIS Online. The results of your analysis are saved in a different layer that you're publishing to the WebGIS cloud. So, publisher permission allows you to create map layers, including through the analysis function and via other means. Because you have spatial technology available to you, let's do some analysis and determine how water flows, for example, from your school or from another location. This is part of the analysis tools, as I mentioned, which allow you to overlay map layers, compute spatial statistics, interpolate surfaces, and much more. For now, as I mentioned earlier, we're going to just focus on one tool, Trace Downstream. So if you perform analysis, find locations, and trace downstream. Access that tool, Trace Downstream. Use the tool as follows. For number one, when you're tracing downstream, click the place marker and drag it to the point on the map that you want to trace downstream from. It should drop the point on the map and you will see it. For number 2 in that dialog box, make the maximum distance 5,000 kilometers. For number 3 in that dialog box in the analysis tool, give the resulting map layer with your stream trace a suitable name. Do not check the Use Current Map Extent box, or conversely zoom out until you see all of Australia, and then it would be okay to check the box. But generally it's better not to use the current map extent when you're running this tool. Then you don't have to worry about it. When done, run analysis. Be patient while it considers elevation and stream hierarchy and flow to compute the trace. So when you think about what's going on behind the scenes, it's really pretty remarkable. When done, examine the spatial pattern of your result, noting direction, cities, and landform areas that the water passes through, and the location where your water enters the ocean. Use the Measure tool to measure the distance. To see your stream trace more clearly, change the style to red or orange, or just increase the thickness of the line symbol to a thick blue line. In this example, why does water take such a long journey to the ocean when the distance to the south of the point is so much less? Use the Measure tool to measure the straight line distance from your point to the nearest ocean shoreline. And then compare, why doesn't it follow the shortest distance? Well, there's lots of other factors. Diversion of streams, the landforms, etc. Now open the table for the trace layer. Note the value in the length kilometers field. How many kilometers did water from your point need to reach the ocean? How much more in kilometers and in percentage is this from the straight line distance you measured earlier? Go ahead and save your map. Let's talk about extending the lesson. In all of these activities, I give you some content and some tools and some hands-on activities, but you can extend these as you move forward with spatial technologies. You can extend these and dig deeper. There are several ways here that comes to mind to extend the lesson. Because spatial technology is an open problem-solving toolkit, again, you're not confined to only doing what is outlined in this module. First, you could perform trace downstream from other locations around the world. Second, you could add a real-time weather layer to your map and discuss how river flow could be affected by a large rain event or a typhoon or a hurricane, and which cities might need to be placed on alert. Third, you could add stream gauging stations and real-time water flow to this map and examine their values in relation to the rivers and watersheds, investigating the effect of snowmelt or rainstorms on the stream gauge, the location of the stream gauge within the watershed, again using ArcGIS Online. So for example, why is the water flow so much greater where the stream actually enters the ocean rather than near the headwaters versus mouth? Now, you'll explore this further when you map your own data in another component of this module. Well, congratulations. You've investigated hydrography or hydrology using spatial technology. You've opened some maps, built your own maps, and again, because spatial technology is a platform, people build customized applications on top of it. So for example, in another section of this module, you'll look at the Queensland Globe application. That's an application that's based on these spatial technologies. Thanks.